All right, so ready to dive into something that's been causing like a major stir in philosophy circles.
Oh, absolutely. Always up for a good philosophical deep dive.
It's Bayesian epistemology. And picture this, okay?
Mhm.
We're at this huge philosophy conference, the kind where everyone's buzzing with ideas.
Ah, yes. The air is thick with arguments and caffeine.
Exactly. Presentations are wrapping up, and now everyone's kind of spilling out into those hallways, right, to debate the hot topics. And guess what's on everyone's mind?
Let me think. Could it be this Bayesian thing everyone's talking about?
Bingo. It's all about this Bayesian stuff.
It really is fascinating how Bayesianism has captured the attention of so many philosophers. It's not just some niche topic anymore. It's popping up in discussions about, everything, from the nature of belief to the philosophy of science.
I know, right? It's everywhere.
Mm.
And to really get to the bottom of this whole Bayesian thing, we're going straight to, the ultimate source. The Stanford Encyclopedia of Philosophy's entry on Bayesian epistemology. We're talking thought experiments, paradoxes, the whole 9 yards.
We're going deep. Buckle up, listeners. It's about to get conceptually adventurous.
Get ready to, totally rethink how we know what we know. Okay, so first things first. What exactly is Bayesian epistemology?
Right, to the heart of it. Well, the key shift with Bayesianism is that it's not simply about believing something or not believing it. It's about degrees of belief.
Degrees. So it's not just, yep, I believe that, or nope, don't believe it at all.
Exactly. There's nuance. It's more like a spectrum of how strongly you believe something. And we call these degrees of belief credences.
Okay, credences. So instead of just saying, I believe in X, Bayesian would say what, my credence for X is, I don't know, 0.8.
That's the idea. That number, that 0.8, well, it represents how strong your conviction is. It can range from 0, meaning no belief at all, to 1, meaning absolute certainty.
Oh, I see. So it's like a sliding scale of how sure you are.
Precisely. And that's what allows for so much more detail and nuance than a simple yes or no to a belief.
Yeah, that makes sense. I can definitely see how this would appeal to philosophers who, they love to dive into those shades of gray.
Absolutely. Shades of gray are where the really interesting philosophical questions lie.
But hold on. If we're talking about these credences, how do we make sure they're, actually rational? Can I just, randomly assign numbers to my beliefs and call it a day?
That's where things get interesting, and that's where the two core norms of Bayesianism come in: probabilism and the principle of conditionalization. So, starting with probabilism. At its core, it says that your credences, they have to play by the rules of probability. They need to add up in a way that makes sense.
Oh, so if I'm 70% sure it'll rain tomorrow, then my credence that it won't rain has to be 30% because they have to add up to 100%.
You got it. It's like fitting pieces of a puzzle together. All your credences, when expressed as probabilities, they need to fit together without any contradiction.
Okay, I'm following you. It's like a coherence check on my beliefs. They can't be all over the place.
Exactly. They have to hang together in a logically consistent way.
Gotcha. All right, so that's probabilism. But what about this conditionalization thing? What's that all about?
So conditionalization is all about how your beliefs are supposed to change when you get new evidence. Think of it as the Bayesian way of updating your mental model of the world.
Updating, huh? Interesting. So let's say, for example, I have a certain credence that all swans are white. Then, boom, I see a black swan.
Right.
What happens then in Bayesian terms?
That's the classic example. Conditionalization gives us a precise way to figure out how much your credence should change. And it all depends on two things: how strongly you believed all swans were white before you saw the black swan, and how strong the evidence of that black swan is.
So it's kind of like the scientific method, right?
Yeah.
You have a hypothesis, then you make some observations, and then you adjust your beliefs based on what you see.
The connection to science is definitely there. But what makes Bayesianism unique is how mathematically precise it is about this belief updating process. It's not just, oops, I guess I was wrong. It's a calculation.
A calculation, oh man.
It's a calculation of how your credence shifts based on the strength of the evidence.
Yeah, okay. I'm starting to see how this could get really interesting for philosophers of science, especially when you think about how theories are confirmed or disconfirmed by evidence.
Absolutely. And that's where we start to see some of the really fascinating applications of Bayesianism. Take the confirmation of Einstein's theory of general relativity.
Oh, yeah. Eddington's observation of starlight bending during a solar eclipse, right? That was a huge win for Einstein.
Exactly. It was a classic case of a theory getting a massive credence boost from surprising evidence. Because the observation fits so well with Einstein's theory, it made a lot of scientists much more confident that the theory was correct.
That makes sense. The more unexpected the evidence, the more it makes you rethink things.
Yeah.
But what about cases where the evidence isn't so clear-cut? Like where it doesn't perfectly prove or disprove a theory?
Well, that's where things get even more philosophically intriguing. Think about the classic problem of enumerative induction. Imagine for a moment that you've observed hundreds, maybe even thousands, of black ravens, but never a single raven that isn't black. Does this strengthen your belief that all ravens are black?
I mean, hundreds of black ravens and not a single one of any other color. That's got to count for something, right?
Well, from a Bayesian perspective, the answer is it depends. And that's where this idea of priors comes into play.
Priors. Okay, now you're just throwing jargon at me. What are priors?
So your priors are basically your beliefs before you get any new evidence. Like in the raven example, if you started out already super convinced that all ravens are black, then seeing hundreds more isn't going to change your mind that much.
But if you started out kind of skeptical, then all those black ravens would really make you think.
Exactly. The impact of the evidence depends on your prior beliefs.
I see, I see. So where do these priors come from in the first place? Are they just totally subjective, like whatever I happen to believe? Or is there some objective way to figure them out?
That is the million-dollar question. The origin and justification of priors, well, it's one of the most hotly debated issues in all of Bayesian epistemology. It really gets to the heart of what rationality is and how we know anything at all.
I can see how that would be a big deal for philosophers. It's not just about the math anymore. It's about like what those numbers mean for our understanding of knowledge.
You've got it. And that tension between the mathematical formalism and the philosophical implications, well, that's what makes Bayesian epistemology such fertile ground for debate.
Yeah, I'm definitely starting to get a feel for that. Okay, so before we go too far down the philosophical rabbit hole, let's talk about something that always seems to pop up whenever people talk about Bayesianism. The Dutch book argument.
Yes. The Dutch book argument. It's a classic way of showing what can happen, practically speaking, when your beliefs are irrational.
Like, would all get bad grades?
Not exactly. It shows that if your credences don't follow the rules of probability, well, someone could, theoretically, cook up a series of bets that would guarantee you lose money no matter what happens.
Wait, so if my beliefs are all over the place, I'm basically a walking target for someone to, like, take advantage of me.
In a way, yes. The Dutch book argument shows that being irrational can have real-world consequences. It gives you a practical reason to make sure your beliefs are coherent.
Okay, that makes sense. But I bet philosophers aren't satisfied with just a practical argument, right? They want to know if there's, like, a deeper reason, an epistemic reason, to be a good Bayesian.
You're exactly right. The Dutch book argument, while it's compelling in its own way, doesn't really address the question of whether having accurate beliefs is inherently valuable. It focuses on the consequences of being wrong, not on the value of being right.
So that's the real philosophical challenge, huh? To figure out why accuracy matters.
Precisely. And that's where things get even more interesting.
Well, we've covered a lot of ground already. We've explored those core norms of Bayesianism. We've touched on those tricky priors, and we've even dipped our toes into, well, the practical implications of irrationality.
We've set the stage for a deeper exploration.
But the real philosophical fun is just beginning.
Welcome back to our Bayesian adventure.
Round 2. I'm ready to go deeper into this Bayesian rabbit hole.
Well, as we saw in that last part, right, the Dutch book argument gives us this pretty strong reason to try and be rational with our beliefs, at least if we don't want to end up losing all our money to some clever bookie.
Yeah, that's a good point. Nobody wants to be the sucker at the betting table. But it feels like, for philosophers at least, there's like a bigger question lurking behind all this,
Oh, I think you're spot on.
It's like, why? Should we care about having accurate beliefs in the first place?
Yeah.
Like, is it just about avoiding bad consequences? Or is there something, I don't know, something more inherently valuable about truth itself?
You've hit on a key point that a lot of philosophers wrestle with, and it's this search for an epistemic foundation for Bayesianism, like what's the deeper justification for all this? And this has led some philosophers to really zero in on this idea of accuracy.
Accuracy, huh? Okay, I'm listening.
So it's all about how well our beliefs actually line up with reality. Like, how well does our mental map match the actual territory?
Okay, so a belief is accurate if it corresponds to reality. Seems simple enough, right?
Well, defining accuracy in a philosophically rigorous way, that's a whole other can of worms. But the basic idea is that, if our goal is to have true beliefs, then the more accurate those beliefs are, well, the better.
Yeah, that makes sense intuitively. But how does accuracy tie into this whole Bayesian system with credences and all that? Like, how do they fit together?
Okay, so imagine you've got a bunch of different hypotheses about how the world works, right? And you're trying to figure out which one is the most likely to be true. Some Bayesians argue that you should pick the hypothesis that, if it were true, would make your overall set of beliefs the most accurate.
Oh, okay. So it's not just about individual beliefs being accurate. It's about the whole system of beliefs fitting together in a way that kind of maximizes the overall accuracy.
Yeah, got it. It's like you want a system of beliefs where the pieces all fit together nicely and they paint a picture that's as close to reality as possible.
I see, I see. And this connects to that whole thing about explanatory power in science, right? Like,
Yeah.
we tend to think a theory that can explain lots of different things is probably more likely to be true than a theory that only explains a few very specific things.
Exactly. The more a theory can accurately explain, the more credible it seems. Like a theory that can explain, not only why apples fall from trees, but also the movements of planets and the behavior of black holes.
Yeah, like Einstein's theory of general relativity. It explains so much more than just the orbits of planets.
Exactly. The more a theory gets right, the more reason we have to believe it.
I'm starting to see how this all connects. But even this accuracy-based approach, it's not like a slam dunk, right? I mean, defining accuracy in a way that everyone agrees on, that's a whole other philosophical debate in itself.
Oh, absolutely. That's where the real philosophical heavy lifting begins. Like, what do we even mean by reality? And how can we ever be sure that our beliefs are actually matching up with it?
Okay, so maybe we'll say that for another deep dive.
Many deep dives, probably.
But speaking of things that get kind of messy, one thing that's always bugged me about Bayesianism is that it often seems to assume we're these, like, perfectly rational beings. Like,
Right.
we're walking around with perfectly consistent beliefs, and we never make any mistakes in our reasoning. I mean, come on. Nobody's that perfect.
You've hit on a common critique, and it's a good one. The problem of idealized agents. Critics of Bayesianism point out that it sets the bar way too high. Like, no human being can live up to those standards of perfect rationality.
It's like expecting everyone to be Spock from Star Trek, instantly calculating probabilities and updating beliefs with flawless precision. I mean, I can barely decide what to have for breakfast some mornings.
Exactly. It can feel pretty unrealistic. And philosophers have raised some serious concerns about this. For example, standard Bayesianism often assumes this thing called logical omniscience.
Logical omniscience. Okay, now you're just using big words to try and intimidate me.
Not at all. It's actually a pretty simple idea. It just means that, logically speaking, we're aware of all the implications of our beliefs.
Implications.
Right. So, like, if I believe that all cats are mammals, and I believe my pet Whiskers is a cat, then I must also believe that Whiskers is a mammal, even if I've never explicitly thought about it that way.
Oh, I see. It's like my beliefs have to be logically airtight with no gaps or contradictions.
Exactly. But of course, in reality, nobody actually thinks like that all the time. We miss logical connections, we jump to conclusions, we have biases, we get distracted. We're human. And that ideal of always being perfectly logically consistent, well, it just doesn't really match up with how our minds actually work.
It's a bit too neat and tidy for real life.
Right, it is. So the question is, how do Bayesians deal with this? Do they just shrug and say, well, good luck trying to be perfectly rational, even though you'll never actually get there?
Yeah, is it just like aspire to be a Bayesian superstar, even though you're doomed to fail?
Well, some Bayesians do kind of take that route. They say that perfect rationality is this ideal we should strive for, even if it's ultimately unattainable.
Okay, fair enough. Aim high. Right. But are there other Bayesians who, like, try to make the theory a bit more down to earth, a bit more applicable to, us messy humans?
Absolutely. There are definitely Bayesians who are trying to find ways to de-idealize Bayesianism to make it more realistic and, well, more humane.
Okay, now we're talking de-idealize Bayesianism. I like the sound of that. But how do you actually do that? How do you make a theory about perfect rationality less? Well, perfect.
Well, one way is to relax that super strict requirement of perfect precision. Instead of saying our credences have to be these exact numbers, maybe it's enough to have, like, ranges or intervals of belief.
So instead of saying my credence in this theory is exactly 0.6, I might say, Well, my credence is somewhere between zero point 0.5 and zero point 0.7.
Precisely. And this makes a lot more sense when you think about how we actually reason in real life. We're often unsure, we hedge our bets, we estimate. We don't always have these super precise degrees of belief about everything.
It's like embracing the fuzziness of human thought. I like it.
Another move is to just acknowledge that we don't have beliefs about every single thing in the universe.
Oh, thank goodness. Because I definitely don't.
Like, you probably don't have a strong opinion on, the exact number of grains of sand on Mars.
Nope, definitely not. Or, what the weather was like in ancient Mesopotamia on, I don't know, July 12th, 3000 BC. Some things are just not on my belief radar.
Exactly. And Bayesianism can actually handle this. It allows for what we call credence gaps. These are areas where we haven't really formed any kind of belief one way or the other. And this acknowledges that, our minds have limits. We can't be expected to have an opinion on absolutely everything.
It's like admitting that our mental maps of the world are incomplete. Like there are blank spots, unexplored territories.
I love that analogy because that's exactly what it is. It's recognizing that we haven't charted every single corner of reality.
This is making a lot more sense to me now. But doesn't de-idealizing Bayesianism, I don't know, doesn't it create new problems? Like, if we're allowed to have these credence gaps, how do we decide what should be on our belief radar? What are the rules for figuring out what we should even bother forming beliefs about?
Brilliant question. And you're right, de-idealizing Bayesianism doesn't make things simple. It just opens up a whole new set of philosophical puzzles. Like, what are the criteria for rational belief formation when we're dealing with limited cognitive resources? When do we need to have a belief, and when is it okay to just say, I don't know?
It's like instead of solving the problem, we've just created a whole bunch of new ones.
Well, that's the beauty of philosophy, isn't it? One question answered often leads to 10 more questions.
True enough. But these questions get even more tangled when we start to think about, well, the role of time in belief formation. Those situations where the evidence is old, or a new theory suddenly changes how we see past events.
Yes. The tricky relationship between Bayesianism and time. That's where things get really interesting.
And by interesting, you mean mind-bendingly difficult, right?
Maybe a little of both. Because these situations really challenge that standard Bayesian view of belief updating, which is often seen as this very linear process, right? New evidence comes in, we update our beliefs, and so on. But what happens when our understanding of the past itself becomes uncertain?
It's like suddenly realizing that the map you've been using your whole life was, well, slightly off.
A perfect analogy, because suddenly all those familiar landmarks look different and you have to figure out where you are all over again.
Yeah, that's a good way to put it. But give us a concrete example, something we philosophers can really sink our teeth into.
Okay, so let's consider that famous case with Einstein and the orbit of Mercury. For centuries, astronomers had been puzzled by this little quirk in Mercury's orbit that just didn't fit with Newtonian physics.
Newtonian physics, that was the big theory before Einstein came along, right?
Right, exactly. And so everyone's trying to figure out why Mercury's orbit is doing this weird thing, but no one can quite explain it using Newton's laws. But then Einstein comes along with his theory of general relativity, and boom, it perfectly explains the anomaly.
So he basically just came up with a new way of looking at the same evidence, right?
Yeah.
He didn't collect any new data or anything.
You got it. It was a total shift in perspective. And this shows how powerful a new theory can be. It's not always about getting new data. Sometimes it's about looking at the data we already have in a completely new way.
It's like those optical illusions where you see one image and then suddenly you see something totally different. The lines haven't changed, but your perception of them has shifted.
Exactly. And this poses a real challenge for the standard Bayesian view of conditionalization. Because remember, conditionalization is all about updating your beliefs in light of new evidence. But in this case, there isn't any new evidence in the usual sense.
So the question is, should our beliefs change even when the evidence stays the same, just because we have a new theory that makes more sense of it?
Precisely. And that's a question that philosophers are still debating. How do we account for these shifts in perspective that can completely transform our understanding of the past?
Yeah, that's heavy stuff. It's like our beliefs about the past are constantly being rewritten as we learn more about the present. It makes you wonder if we can ever really know anything for sure.
Well, that's the nature of knowledge, isn't it? It's always evolving. And these challenges related to time and memory, they lead us to some of the most mind-bending thought experiments in all of Bayesian epistemology.
You're talking about the infamous Sleeping Beauty problem, aren't you?
The one and only. It's the thought experiment that's been keeping philosophers up at night for decades. And for good reason, because it really forces us to confront some very strange and deep questions about the nature of time, belief, and subjective experience.
All right, philosophy fans, welcome back. We're in the final stretch of our deep dive into Bayesian epistemology.
The grand finale.
And things are about to get really, really interesting. We've talked about credences, we've wrestled with those tricky priors, we've even explored those idealized agents.
You've covered a lot of ground, but there's still more to explore.
But now we're heading into a territory that, honestly, just kind of messes with my intuition. The world of self-locating beliefs.
Ah, yes. Self-locating beliefs. Those beliefs about, well, ourselves, our position in time, in space, our very identity, they seem so basic, right? So fundamental to how we experience the world.
Yeah, like, I am here, Nell Hawley. Seems pretty straightforward.
You'd think so, but they create these incredibly perplexing puzzles for Bayesianism.
Okay, I'm intrigued. Hit me with a philosophical brain twister.
Yeah.
Something that would make Descartes himself scratch his head.
All right, challenge accepted. Imagine a writer, super focused, working late into the night on her latest masterpiece. She's so engrossed in her work that she completely loses track of time.
Oh, I've been there. Deadline pressure can do that to you. You just blink and suddenly it's 3 a.m.?
Exactly. Now imagine she finally looks up from her work and she realizes it's dark outside. But she has no idea whether it's, say, Wednesday evening or early Thursday morning.
Okay, I'm starting to get a sense of where this is going. Lost track of time, gotta adjust her plans. Simple, right?
Well, hold on. Let's say she's also way behind schedule. She's got only a fraction of the work done that she thought she had. So she needs to update her belief about how much she still has left to do. Seems like a classic case of Bayesian updating, right?
Yeah, new information, adjust the beliefs. But I have a feeling you're about to throw a curveball.
You know me too well. The problem is this. What exactly is the evidence she's updating on? Is it, I still have 2 chapters to write on Wednesday evening? Or is it, I still have 2 chapters to write on early Thursday morning?
Oh, I see. Those are 2 totally different things. And since she doesn't know what day it is, it's like, which evidence should she use to update her belief?
Exactly. And that's where things get tricky for standard Bayesianism, because our beliefs can change even when we don't have explicitly new evidence. Sometimes it's not about a lack of information. It's about confusion about our own position in time.
Right. It's not like she's learned anything new about the amount of work she has to do. It's just that her sense of where she is in time has gotten all messed up.
Precisely. And this highlights how limited that classic Bayesian framework can be sometimes.
Okay, so this brings us to, I'm guessing, the infamous Sleeping Beauty problem, right? The thought experiment that's been driving philosophers crazy for years.
You guessed it. The Sleeping Beauty problem takes this whole issue to a whole new level. It's a classic example of how time, memory, and self-awareness can really throw a wrench into those Bayesian gears.
Lay it on me. I'm ready to have my mind blown.
Okay, so picture this. You're Sleeping Beauty, and you're part of this really weird experiment. You're put to sleep, and then a fair coin is flipped. If it lands heads, you're woken up once on Monday, and then the experiment is over. But if the coin lands tails, you're woken up on both Monday and Tuesday. But each time you wake up, they give you amnesia, so you don't remember the previous awakening.
So basically, I'm Sleeping Beauty, and I know the experiment is happening, but I have no idea what day it is or if this is the first time I'm waking up. I'm already feeling dizzy.
And the million-dollar question is, when you wake up, what should your credence be that the coin landed heads?
Okay, let me think. My gut reaction is to say it should still be 50-50. Like my initial credence before I went to sleep. Because, I mean, I haven't actually learned anything new about the coin itself. Like, I'm just waking up in a room.
That's a natural response. And honestly, a lot of Bayesians would agree with you. But there's another way to look at it, one that gets really weird and really challenges our intuitions about evidence and time.
Okay, hit me with the weirdness. I'm ready for it.
So some philosophers argue that your credence should actually drop to 13 when you wake up.
Wait, what? 13? How does that make sense?
Okay, here's their reasoning. There are 3 possibilities, and they're all equally likely, right? Heads Monday, tails Monday, and tails Tuesday. But since you're only asked for your credence when you're awake, and 2 out of those 3 possibilities involve tails, well, your credence should reflect that higher probability of being in a tails world.
Whoa. So the fact that I'm being asked the question, the fact that I'm awake and having this experience, that's actually part of the evidence I need to consider.
Exactly. It's like your own state of awareness, your location in time is a data point that you have to factor into your beliefs.
I told you this was mind-bending. It's
Mhm.
like Bayesianism is starting to turn in on itself,
Mhm.
making us question the very nature of belief and evidence.
And that's what makes these thought experiments so fascinating. They push us to the very limits of our understanding.
So where does this leave us? Are we just stuck with this paradox?
Well, not necessarily. The Sleeping Beauty problem and other puzzles involving self-locating beliefs, they've really forced Bayesians to come up with more sophisticated accounts of how our beliefs change over time. Some propose tweaks to conditionalization, making it more sensitive to those temporal aspects of our experience. Others are exploring even more radical departures from standard Bayesianism.
Like what? Give us a taste of the radical.
Well, one really intriguing idea is something called time slice Bayesianism.
Time-slice Bayesianism. Okay, that sounds kind of sci-fi. Break it down for me.
So, time slice Bayesianism says that what really matters is having rational beliefs at each moment in time, based on the evidence you have at that moment. It's all about being rational in the now, regardless of what your past self believed.
So it's like saying, my past beliefs, irrelevant. What matters is what I believe right now.
In a nutshell, yes, it's a way of kind of sidestepping all those messy issues of memory, belief revision, and how beliefs change over time.
Sounds like a pretty radical departure from how we usually think about belief.
It is, but that's what makes it so interesting. And of course, it comes with its own set of philosophical challenges. Like, how do you even define a moment in time? And if our past selves are irrelevant, what does that say about personal identity and the continuity of the self over time?
So many questions. But I think the key takeaway here is that Bayesian epistemology isn't this, like, finished, closed book. It's a vibrant, ongoing area of research and debate. It's a conversation that keeps evolving as we encounter new puzzles and grapple with the complexities of human reasoning.
I completely agree. And I hope our listeners are walking away from this deep dive with a sense of both the power and the limitations of Bayesianism. It gives us these amazing tools for understanding how we form and update our beliefs. But it also forces us to confront these really profound questions about, well, about knowledge itself.
It's like Bayesianism is holding up a mirror to our own minds, showing us both the incredible rationality, AD, the surprising irrationality of human thought.
Beautifully put. And that's what makes philosophy so endlessly fascinating. It's not about finding easy answers. It's about embracing the mystery and the constant pursuit of deeper understanding. So the next time you find yourself, pondering a belief or weighing evidence or making a decision, try thinking about it from a Bayesian perspective. You might be surprised by what you discover.
It's a whole new way of looking at the world and at ourselves. Until next time, keep those philosophical gears turning.